So I'd say a third of our students go into graduate school, a third of our students end up being a teacher, a physics, like a high school physics teacher, and the other third go into something like industry, or just there are a lot of jobs out there that just look for science majors and physics majors because there's been analytic skills involved with that degree. So we prepare for all three of those paths. I would say more so than I would say there's more demand for physics than in other fields, but it's not quite at the point where it's like people are scrambling to hire you. It's not that kind of a shortage, but physics teachers are more in demand than other fields. And you don't offer a graduate program here, right? No, we do not have a graduate program. Do many of your graduates, the students that take physics here, do they get scholarships to graduate programs very often? So usually actually in the sciences, in almost any science, students tend not to have to pay for graduate programs because they will get hired either as a research assistant or as a teaching assistant while they're in graduate school. So I think actually, no matter what school you come from, it tends to be that students generally don't have to pay for their graduate program. 2 years. So a master's would be 2 years, a PhD would be like 6 years. We have a new telescope on campus. We also have a planetarium on campus that right now is about to get a planetarium show. So if you're interested, Dr. Nunes here is going to walk over to lead people to the planetarium show. If you guys have time, you can maybe do that now. And actually, 2 students are giving the show, so you get a chance to see how students get to be involved with the program.
So no pressure, but I'm about to head over there. You're welcome to come, and then you can talk to me about physics and astronomy, or you can stay here and talk to me about physics and astronomy.
I'm the junior faculty. Larry here can show you some of the options that help us run it, but I will show you that it's like
what is this copper pipe apparatus?
Yeah. I don't.
Yep. You drop it in here. Falls down.
Just lower. Right.
Coming right through. Here it comes. Any minute now. Here it comes. It came right through. Now, just to convince you it didn't get stuck, do this. Actually, it's moving a little faster now because of the weight of the plastic. And without the plastic, it takes 17 seconds. And the way it works is you take a wire, make it a loop, you push a magnet to it. Generate a current on the wire, and that produces a magnetic field pushing up. So you've got a magnetic field pushing up, the weight of the magnet pushing down. Gravity's going to win, but it takes a little longer.
Yeah.
And finally, this is a Stirling cycle engine. This was Stirling invented in 1816, long before gasoline and diesel engines. The only thing they had in those days were steam engines. Now, what happened was they didn't have the technology to build good boilers, so they kept blowing up. And he was fed up losing all his parishioners. So he said, I'm going to build an engine that doesn't use steam. So he built a hot air engine. You can see the one piston going up and down in here. It's a large one. There's a smaller one on the back side. And it's variable. And what this is doing is it's transferring heat from one side to the other, back and forth, and it's doing work. Now, here's the power source.
Advanced light source.
Ice.
August. And they had one of those.
Now, I just told you this is a heat engine. Where's the heat? It's heat in the room, going down
At
to
first,
the engine,
24 hours a day, so it was always hot coffee.
melt that ice up. And in the process, it's doing work.
Not a bad idea.
Now, if I had taken ice and made it hot water, then the heat would come.
So that's not a program that we have for underrepresented students.
And go backwards.